Algebra 1, Lesson 43, we are simplifying rational expressions. So these are expressions that have variables in the denominator. And one thing that we have to make sure that we look out for is the fact that a rational expression can become undefined if the denominator equals 0. So if we have that variable in the denominator, we need to make sure that we exclude a value or values that would make the denominator 0 because we don't want an expression to become undefined. So in this case, first we look and we say, can we simplify anything here? And it may be tempting to try to simplify this x and this x, but remember, when we are simplifying things that are with division, we are only able to simplify factors that are in the numerator or denominator. In this case, 5 and x in the numerator are addends. They are connected with addition. 9 and x are factors because they are connected with multiplication, but we cannot simplify an addend and a factor. So in this case, actually, we are in the most simple form. Second step is we want to figure out what would make the denominator 0 so that we can exclude that value for our variable. And one way to do this is making that denominator equal to 0. So we would say 0 equals 9x and solve for x. So we divide by 9 and see that x would have to be 0 in order to make the denominator 0. So since we don't want the expression to be undefined, x cannot be 0. Because if we plugged in 0, 9 times 0 is 0, and that would make the expression undefined. So this is what we're going to do for each of our expressions. We're going to simplify it as much as possible and then see when is x undefined. So 2 plus x over 10x, just like the last one, I can't simplify those x's because they're not both factors. Okay, and so I figure out what can x not equal? Well, x can't be 0 because if I plugged it in, 10 times 0 is 0. So we would say that x cannot be 0. How about this one? 7x plus 1 over x minus 7. Well, because the numerator, these are connected with addition, this is connected with subtraction, there's nothing to simplify. And so we say, all right, nothing to simplify, we're in our simplest form, let's figure out what x cannot be. Well, we set our denominator equal to 0, so 0 equals x minus 7, and we solve for x. So we do the opposite of minusing 7, so we add 7 and say that x would be 7 if we to make this undefined. So x cannot, we exclude 7, x cannot be 7. And next one. 2x plus 1 over x minus 4, can this be simplified? And you would say no, this cannot be simplified. That 2 and that 4, those are tempting, but remember, 2x is an addend, 1 is an addend. X and 4 are part of a subtraction problem, so minuend, subtrahend, those words come to mind. And so they are not factors, we cannot simplify them. So we go into what would make this undefined. So x minus 4 equals 0. We add 4 to each side and see that x would be 4 if this were undefined, so we exclude 4. All right. So here is our kind of way of going about this, and I'm going to switch this up just a little bit. So first, we are going to simplify the rational expression if possible. We do this first because sometimes, and I'll show you an example of this in a second, sometimes we actually end up getting rid of the variable or a variable in the denominator, and so we can actually have that one. 2, we set the denominator equal to 0, and 3, we figure out when would make this undefined, what value for x would make this undefined. So let's look at a couple of examples. So let's first look at x plus 5 times x minus 3 over 3x plus 21. Well, it might be tempting to multiply out the numerator, but I would leave it as it is because right now we actually have factors. X plus 5 is a factor and x minus 3 is a factor. Okay, those quantities are factors. So my goal is to say, can I factor the denominator to get something that is similar, something that I can cross out? And so we say, what is in common between 3x and 21? And we say 3 is in common. And so we pull it out of each and we have x plus 7 left over. And now we have two factors in the denominator. We have 3 and we have x plus 7. But because neither of those are similar, or let me say exactly the same to what's in the numerator, we don't have anything to simplify. So this is the simplest form. And we go into, well, set the denominator equal to 0. And I can use either form, the factored form or the expanded form. I'm going to use the expanded form right now. And I solve for x. So I subtract 21. And so I have 3x equals negative 21. I divide by 3. And I get x would have to be negative 7 to make this undefined, which would make sense because if we plugged in a negative 7 plus 7 is 0, times 3 is 0. So we exclude x equals, we say x cannot be negative 7. Now on this next one, we do the same thing and we want to factor the denominator. And so we go ahead and say 5 is in common, so we get x minus 3 in the parentheses. And in this one, we realize, well, this factor of x minus 3 and this factor of x minus 3 are exactly the same. So I can cancel those out. And I am left with 2x plus 1 over 5. And in this case, if we had originally looked at it and said, no, it can't be simplified anymore, I would have to set 5x minus 15 equal to 0, and I would have to exclude 3. But when we simplify, we realize there is no variable in the denominator in the simplified version, and so we don't have to exclude anything. Any x value is okay. And this is why we simplify, to make sure that we have all of the options possible. So let's look at a couple other examples. I'll go through these quickly. For this one, we can't simplify anymore, and we say x cannot be negative 4, because that's what would make this the denominator 0. Let me just erase a few things here. All right, so we exclude x cannot be negative 4. Next one. 27x plus 9 over x minus 10. Once again, we don't have any simplifying to do. These are all add-ins, but we could check to make sure. You know, I might have missed something in the top one. I'll go back and check it in just a second, but let's continue focusing on this second one. Let's make sure and factor the numerator. So we say 9 is in common with both of them. And so we have 3x plus 1 left over x minus 10. Nothing is in common, so we say this is the simplest form, and x cannot be 10. And for the top one, we need to factor it. Okay, so we check and make sure 9 is in common, so we say we have 6x plus 1 over 4 plus x. There is nothing to simplify, but we do need to check. So we still have x cannot be negative 4. Okay, let's try some other ones. All right, now we need to factor both numerator and denominator. So I look at 2x squared and negative 10x and say a 2 is in common with the numbers and 1x is in common with those variables. So I pull out a 2x. And I have left over x minus 5. And then I look at the denominator and say, I can also pull out a 2x from there. So I have 2x times 2x plus 3. Remember, if you don't remember how to factor, go back to that lesson and reteach yourself. But when we look at this, we see, okay, I have a factor of 2x and x minus 5. And then I have a factor of 2x and 2x plus 3, which means these 2x's can cross out and simplify. And so I'm left with x minus 5 over 2x plus 3. And so I set 2x plus 3 equal to 0. I subtract 3 on each side to get 2x equals negative 3. Divide by 2, and I see that x would have to be negative 3 over 2 to make this undefined, so we exclude it. So we see in a little bit clearer form, x minus 5 over 2x plus 3 is our answer. X cannot equal negative 3 over 2, and since we have simplified, we don't have to say that x cannot be 0. So we continue on, and we want to factor both the numerator and denominator of this next one. And in the numerator, we say, okay, 4x can be taken out. 4x times 2x minus 1 over, well, we can take out another 4x times 3x plus 2. And these factors of 2x minus 1, 3x plus 2, they don't have anything in common, but the 4x, I can get rid of those. Now I have to set 3x plus 2 equal to 0. Subtract 2 to get 3x equals negative 2. And divide by 3 to get x would have to be negative 2/3 to make this undefined, so we exclude that value. Okay. Let's go through just a few more examples. I'll let you, if you want to pause the video and look at these, you can check your answers here. Okay, in this case, we simplify it to x over 2, and I would say because we simplified it, we actually don't have a value that is excluded. We would get x cannot be 7 if we did the equaling to 0 before we simplified. And same with this bottom one. 7x over 5, we can actually have anything because there is no variable in the denominator. Okay, let's try this one. The expression 3.5t plus 0.7t squared represents distance of a moving object. The expression 1.4t squared represents the distance the same object moves from the rest with twice the acceleration. Simplify the expression. Well, we need to do some factoring. And if this were 35t and 7t squared, it'd be a little bit easier to see, but those numbers have 0.7 in common and 1t, so I pull out a 0.7t, and I have left over, well, 0.7t can come out of 3.5t 7 times, or sorry, 5 times, good grief, 5 times, and it can come out of 0.7t squared, well, I have a t left over because it comes out of the 0.7 once, and the t comes out once, and so we have a t left over. And I still have my 1.4t squared. Now we look at this and we see, can we simplify anything? Well, we look at our factors. 5 plus t is a factor, 0.7t is a factor, and 1.4t squared is a factor. And while none of these look exactly the same right now, because we're talking about division and fractions, I can see that, well, this 0.7 and 1.4, I can get 1.7 out of here and 2 0.7s out of here. And with the t's, I can get 1t, and 1t is left over on the denominator. So I am left with 5 plus t over t. And in this case, t cannot be 0. All right, 2 more examples on here. Similarly, okay, we are going to look at this one and factor the numerator, and a 0.9t can come out. So we are left with 9 plus t over 1.8t squared. And very similarly, we can simplify and say 1, 2, because 1.9 can come out of 0.9, 2 0.9s can come out of 1.8, and we can simplify the t's to have just 1 t left over in the denominator. So I have 9 plus t over t, so t cannot be 0. And last one here. We have this expression when we're looking at surface area and volume, and we want to see, can we simplify it? And yes, we can. We can factor the numerator to take out a 2, a pi, and an r. And so we have left over h plus r over pi r squared h. So we look at our factors, and unfortunately these h's can't simplify because one of them is an addend connected to that r, one of them is a factor, so we have to leave it alone. But I can get rid of the pi's, both of those are factors, and I can get rid of one r in both the numerator and denominator. So I'm left with 2 times h plus r over RH. And in this case, I actually have R cannot be 0 and H cannot be 0. Well, I hope this is helpful for your homework and for studying.